When you hear the name Albert Einstein, you think genius, right? I mean, of course you do. But what if the very foundation of modern physics, his theory of relativity, is built on one huge fundamental oversight? Okay, let's dive into a really fascinating and, yeah, provocative challenge to pretty much everything we think we know about space-time. This is the big question we're tackling today. It's a question that forces us to hit pause on all the complex equations for a minute and think about the one thing that makes all of physics even possible: the simple physical act of seeing something. So where is this pretty wild idea coming from? Well, it comes from a really deep and detailed blog series out of Japan called Einstein's Negligence. Its anonymous author argues that for over a century, physics has kind of forgotten something fundamental, that we don't experience reality directly. We experience it through information, specifically light, that actually takes time to get to us. All right, so to really get our heads around this, here's how we're going to break it down. First, we'll lay out the main provocation, what this negligence is all about. Then we'll dig into the problem with reference frames, explore this idea of information delay, and pinpoint the exact assumption in relativity that the author is challenging. Finally, we'll see their wild vision for a new physical reality, and then wrap it all up with a pretty big question. So, what exactly is this supposed negligence? What's the big deal here? Well, the author says it's as much a philosophical problem as it is a physics problem. It's really all about the tools we're using to describe the universe. And this right here is an idea the author comes back to again and again. They argue that physics has gotten so obsessed with its beautiful mathematical maps, things like coordinate systems and frames of reference, that it's completely forgotten that they're just that. They're descriptions. They are not the territory. They aren't the physical, actual reality they're supposed to represent. Okay, let's get into the author's first major target for this critique, the concept of an inertial frame of reference. This thing is a total cornerstone of physics, both classical and relativistic. So what is an inertial frame? You can basically think of it as this giant, invisible grid that physicists lay over the universe to map out how things move. The author's whole point is that this grid, it's just an idea, a tool. You can't touch it, you can't see it, but we treat it like it's a real part of the universe. So the author says, let's scrap that abstract grid. What do we replace it with? Something real, a physical observer. The blog calls it the camera eye. And this isn't some abstract point of view, it's a physical thing sitting at one single location in space, just gathering information from the universe around it. And the author makes a great point here. This isn't the first time we've done this in science. Think about Kepler. He did this amazing work mapping the planets, but he did it by assuming the stars in the background were totally fixed, which of course they aren't. The argument is that these inertial frames are basically our modern version of those fixed stars, a convenient map that we've started to mistake for the territory itself. And this right here is the absolute heart of the entire argument. Because if reality is what this physical camera eye sees, then we have to deal with the actual physics of seeing. Right, here's the kicker. Seeing is not instant. When you look at an object, you are not seeing the object as it is right now. You are seeing the light that left that object sometime in the past. There's always an information delay. And this slide, wow, it really shows the mind-bending result of that information delay. And observer, right here, right now, is actually seeing a whole bunch of different moments from the past all at once. Light from nearby objects gets here fast, but light from a distant star might have been traveling for millions of years. So our present moment is actually this wild mosaic of different pasts. And when you break it down like this, it's just undeniable, right? Light is a physical thing. It has to travel through the electromagnetic field. That journey takes time. Forgetting this simple physical fact, the author argues, is the massive oversight, the negligence, sitting right at the heart of modern physics. Okay, so where's the smoking gun? Where exactly does the author say Einstein's model gets it wrong? Well, it goes right back to one of the most famous thought experiments in the history of science. You remember the thought experiment, right? The one with the train? Einstein says that someone inside a moving train will always measure light moving at the same constant speed, no matter which direction it's going. The author argues that, yeah, that's a neat mathematical rule that works on paper, but it totally ignores the actual physical journey that light has to take through space to reach an observer. Okay, so think about it from the view of someone standing on the station platform. For them,
that light beam from the moving train doesn't just go straight. No way. The train is moving forward, so the light it emits has to travel along this slanted diagonal path to reach their eye. And this drawing from the blog shows exactly that physical path.
So let's put it side by side. On one hand, you have Einstein's principle. Light speed is a constant, c, in all directions inside the train's abstract frame. On the other hand, you have the author's argument. This is just a mathematical rule that ignores the physical path light has to take through the electromagnetic field to reach a real observer outside the train. Okay, so what happens if we actually do it? What if we throw out that abstract grid and build a new picture of the universe based on a real observer and this information delay? Well, according to the author, it completely changes the geometry of space-time itself. And this is the massive shift in thinking. On the left, you've got your standard, neat and tidy Cartesian grid, the map physics has been using for ages. But on the right, that's the author's vision of the territory. It's a brand new geometry where space-time is literally reknitted around what can be physically seen by that one camera eye. And the author is really clear on this point. This isn't just about drawing the picture differently. No, this is meant to be a picture of what reality actually is, from a single physical point in space-time. This shape you're seeing, it's called a light cone in physics, and it is the literal geometry of everything that a real observer can see. It's a picture of information arriving from all those different pasts. This, the author argues, is the true, observable geometry of our universe. Now, why does any of this matter? Well, by starting from the perspective of an actual observer, this kind of model might, just might, give us new ways to tackle some of the biggest mysteries out there, like in quantum mechanics, where the act of observation seems to change everything. So, after going all the way down this rabbit hole, after this pretty radical rethink of physics, we come all the way back to that first big philosophical question. What is reality? Is it the clean, perfect, mathematical map that has served physics so well for so long? Or is it the messy, complex, but physically real world as seen by an observer, a world literally built out of delayed information? The author of Einstein's Negligence has definitely made their case. And now that question, well, that's for us to think about.